Welcome back. In this video, we are going to solve problem 7-1 that is taken from chapter number 7, Internal Forces, and book name is Statics and Dynamic by R.C. Hibbeler, 14th edition. So statement is determine the shear force and moment at point C and D. So you can see this is an overhanging beam. Clear. At point A we have a roller support and at point B we have pin support. The loading is shown 500 pounds, 200 pounds and 300 pounds respectively. So you have to find the shear force and moment at point C as well as point D. So let's start with the solution. What will be the first step? First step is that if you remove this roller support at point A, so you will be having a reaction force which will be represented as AY. Similarly, if you remove this pin support at point B, so you will be having a vertical reaction force which will be represented as BY, and there will be horizontal reaction force as well which will be represented as BX. So we will find this BX, BY and AY by using equation of equilibrium. So first equation of equilibrium we will apply is sum of all moments about point B should be equal to 0 and taking the counterclockwise movement as positive. So you can see about point B as this force and this force is passing through point B. So they are not producing movement. So first movement will be produced due to this force. So this force is AY and the perpendicular distance is this one, which is equal to 14 feet. So, and this is producing clockwise movement, so it will be taken as negative. So I can write it as AY multiplied by 14 feet and this is negative. The second movement that is produced due to this 500 pound load and the perpendicular distance is 8 feet and this is producing counterclockwise movement, so it will be positive. So I can write it plus 500 multiplied by 8. And the last moment that is produced due to this 300 pound force and perpendicular distance is also 8 feet and this is producing clockwise movement, so it will be negative. So we can write it minus 300 multiplied by 8 is equal to 0. So from here we will get 14 AY plus, we will use calculator, 500 multiplied by 8 is 4000 minus 300 multiplied by 8 is 2400 is equal to 0. So now 4000 minus 2400 will give you minus 14 AY plus 1600 is equal to 0. So from here this 14 AY will be equal to 1600 and from here we will get AY will be equal to 1600 divided by 14. So I will take 1600 divided by 14 is actually AY comes out to be 114.285 which will be round off to 29. So this is 29 pounds. So this is your AY. Okay. Now we'll find this BX and BY. So for BX we will use this formula that sum of all forces along X direction must be equal to 0 and force toward right side is taken as positive. So you can see you have only one horizontal force BX is acting and there is no other force, so it means that BX is equal to 0. Okay. Now we'll find the third one BY by using the third equation of equilibrium, and that is sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So one upward force is AY which is positive minus 500 minus 200 plus BY minus 300 will give you the sum of all forces along y direction must be equal to 0. So I will write AY is 114.29 minus 500 minus 200 plus this BY which is upward minus 300 is equal to 0. So from here this BY will be equal to minus 114.29 plus 500 plus 200 plus 300. Clear? And when you calculate this by, so you will get again minus 114.29 plus 500 plus 200 plus 300 is 885.71. Now you can confirm it. If you add all these forces, this is 1000, and if you add AY and BY, it should be also 1000. So 885.71 plus 114.29 is 1000. So it means that AY and BY are correct. So up till now we have find out this AY, clear, BY and BX. Now you have find it. So what we are going to do is that first we will find the internal shear force and moment at point C. So for that we will cut the beam at point C and we will draw the free body diagram. So for segment AC, free body diagram will be, so if I draw this beam like this, so this is your point A where you have only AY, which is how much? 114.29. At this point you have 500 pound force, and that is acting at a distance of 6 feet from this point A. Clear? And this is your point C, which is at a distance of 4 feet from this load. So when you cut it at point C, so what you will have, you will be having one normal force that will be represented as NC. Clear? You will be having a shear force at this face, which is VC, and you will be having a moment, internal moment, which will be MC. So we are going to find this VC and MC by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0 and force toward right is positive. So there is only one horizontal force, NC is there. There is no other force, so it means that NC is equal to 0. Now we'll find this VC by using the second equation of equilibrium, that is sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So vertical forces are 114 minus 500 minus VC is equal to 0. So I can write it minus 114.29, sorry, plus, because this is upward, minus 500 minus VC is equal to 0. So VC will be equal to 114.29 minus 500. So I can write it 114.29 minus 500 will give you minus 385.7. So we will write it, this VC is 386 minus 386 pound. Okay. Since this VC shear force is negative, so it means that our assumed direction of VC, which we have taken here as downward, is wrong. It should be upward. So the correct answer will be, we have VC is equal to 386 pounds upward. Clear? This arrow sign is upward. Now we will find this MC by using the third equation of equilibrium, that is sum of all moment about point C is equal to 0 and taking the counterclockwise moment as positive. So the first movement about this point C is due to this 114.29 force, and perpendicular distance is this 10 feet because this is 4 feet. So I will write it here 4 feet. So this load into perpendicular distance is producing clockwise movement, so it will be negative. So I can write it minus 114.29 multiplied by 10 feet. The second moment is due to this 500-pound force and perpendicular distance is 4 feet, and it is producing counterclockwise movement, so it will be positive. So I can write plus 500 multiplied by 4, and the third external moment is MC, which is counterclockwise, so it will be taken as positive. Their sum must be equal to 0. So it will give you minus 1142.9 plus this is 2000 plus MC is equal to 0. So minus 1142.9 plus 2000 will give you 857.1 plus MC. So MC will become equal to minus 857.1 pounds into feet. Since this M is also negative, since MC is also negative, it means our assumed direction of movement is wrong. It should be clockwise. This should be clockwise. Clear? So we will get this MC will be equal to 857, round off will be 857 pounds into feet, and that will be clockwise. So this is the internal movement at point C. Now what we will do is that we have been asked to find the internal movement at point D. So what we will do is that we will cut this beam at this point. Here we will have two sections. One is this one and the second one is this one. So we are going to take this section because it will be easier to solve it. So I will draw this for segment ED. The free body diagram FBD will be like this. Will be the beam. This will be your point E, and this is your point D. At point E, you can see you have 300-pound load. So we are going to take it 300-pound load downward. Here, distance between D and E is 2 feet. You can check it above. This is 2 feet. So when you cut this beam at section D or at this point, so you will be having one normal load that is acting perpendicular to this face is normal axial load. We will represent it as ND. You will be having a shear force on this face which will be equal to VD, and we will take it upward, and you will be having movement MD that will be taken as clockwise. This is due to convention, and later on we will check whether these are correct or not. Now we will apply the equation of equilibrium in order to find this. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0 and force toward right direction is taken as positive. Only there is one normal load that is acting in x direction, but it is opposite to this, so it will be negative, and there is no other horizontal force, so it means that this ND is equal to 0 pounds. Okay, we will find this Vd by using the second equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So one load that is acting downward is minus 300 plus this Vd which is acting upward. You can see we have taken it upward is equal to 0. So it means that this Vd is equal to 300 pound. This is the internal shear force at section D or at point D. Now the third point is that we will find this moment by using sum of all moment about point D is equal to 0 and taking the counterclockwise moment as positive. So about point D, this force is producing moment. So this force into perpendicular distance is producing clockwise moment. So it will be negative. So I can write minus 300 multiplied by 2. And this external reaction, internal movement, which is MD, is also clockwise. So their sum must be equal to 0. So from here you will get this MD will be equal to minus 600 pounds into feet. The value of M is negative. So it means that assumed direction is wrong. Clear? So MD should be equal to 600 pounds into feet. That will be counterclockwise. Clear? So this is the shear force at point D and this is the moment at point D. And this was all about this problem 7-1. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. Thank you.